Reflecting on chromium. Chromium is an element on the chemical periodic table. Its atomic number is 24. Chromium is a transition metal and has an atomic weight of 51.996. Chromium is a solid metal and in its pure form is bluish-white in color. The element has all the typical properties associated with metals. It conducts heat and electricity very well and is both antiferromagnetic and paramagnetic. When polished, chromium has a lustrous appearance and provides for a very durable surface. When refined to its pure form, chromium is well suited for processing and manufacture. Although originally discovered in Russia in the early 1700s, in the form of what's known as Siberian red lead, chromium in its pure elemental form was discovered by French chemist Louis-Nicolas Vauquelin in 1797. The compound they referred to as Siberian red lead was in reality crocotite, a red crystal form of chromium. Vauquelin crushed the mineral into a fine powder and then isolated pure chromium through a process of acid stripping and reduction. After his initial discovery, he later discovered chromium in several other substances, including an emerald from Peru. Because chromium is the element that gives many minerals their various colors, Vauquelin named the new element chromium, after the Greek word chroma, meaning color. Chromium, when reduced to its pure form, is a very hard yet brittle metal. It's also highly corrosive resistant. It is these qualities that lend it well to industry. Chromium ore deposits are found in more than 40 countries around the world. The top chromium producers are South Africa, Kazakhstan, Russia, Zimbabwe, Madagascar, and India. Both surface and underground mining are used for excavating chromium ore. The ore is commonly mined in its chromic ironstone, better known as chromite. From this mined ore, ferrochromium is made through a process of heating the ore to high temperatures along with coke. This refined ferrochromium is then sent to the plants around the world to be further processed and turned into raw materials to produce goods. While rarely used as a standalone material due to its brittleness, chromium has two major primary uses. Chromium is one of the primary metals used when making steel alloys. Stainless steel has a minimum of 10.5% chromium content, and other steel alloys such as chrome moly have an even higher concentration. Chrome plating is the other primary use of chromium in modern industry. Ferrochromium is widely used as an alloy metal in the production of various types of stainless steel. Most stainless steel grades contain a minimum of 10.5% chromium. The chromium is used for its corrosion resistance and also adds to the hardness of the finished steel. When mixed with the steel, the chromium produces a chromium oxide layer on top of the steel, and if it is scratched, it repairs itself almost instantaneously, providing corrosion resistance throughout the entire part. The addition of the chromium to the iron gives the finished metal its characteristic blue-gray color. The steel alloys are manufactured into raw goods in the form of slabs, sheets, bars, rods, and wires. These are sold to and further processed by manufacturers around the world into the products that we use every day. Chromium alloyed steels, known for their hardness and corrosion resistance, are used in the manufacture of submarine and ship hulls, firearm barrels and high-heat engine parts, kitchen appliances, household fixtures and utensils, tools and various medical equipment, and even automobiles. The DeLorean DNC-12 and the Tesla Cybertruck are two examples. In the later part of the 20th century, we started seeing stainless steel used in both construction and as a visual artistic choice in architecture. Some artists have even chosen stainless steel as their medium for sculpture. These sculptures are often public art pieces and require little to no upkeep due to the hard and invisible protective layer of chromium oxide. The other common use, and probably best known use for chromium, is in the plating industry. Chrome plating, as it is commonly known, is an electromechanical process where chromium atoms are electrically bonded to a substrate material. These plated coatings can be either decorative or, for hard coating, protective uses. The general process of chrome plating involves strict preparation of the base material. These parts need to be both smooth and clean, free from any contaminants that might ruin the finished product. After cleanup and degreasing, the parts are submerged into an electrolyte bath. An electrical current is connected to the part to be plated and an anode of the plating material. Through this process, atoms from the plating material, chromium, are transferred and bonded to the surface of the part receiving the plating. Decorative chrome plating has been used in a wide variety since the early 20th century in cars and motorcycle trim, as well as various other household goods. Chrome plating was at its height in the 1930s through the 1960s, when plastics and painted trims were favored as cheaper options. Another form of chrome plating is hard coat plating. Hard coat plating is typically reserved for tool and industrial machine part manufacturing. While decorative chrome plating is typically between 0.25 and 0.5 microns thick, hard coat plating can be several hundred microns thick. Often the plating is thick enough to be machined down to precise dimensions, as well as retaining an ample thickness of the hard coat chromium oxide layer. In conclusion, chromium, while only discovered in the past 250 years, has come to play a pivotal role in our everyday lives, whether in the form of chrome-plated rims on our cars, or be that of stainless steel refrigerator in our kitchen. The luster chromium surrounds us as one of the most abundantly used materials in the world today.